Hello everyone, welcome to my channel. Today we are going to study these three forms of the integral, that is, first is px plus q upon ax square plus bx plus c. The second one is px plus q upon square root of ax square plus bx plus c. So these two forms is basically in the numerator we have the linear and in the denominator we have the quadratic. Okay, so either you will get a quadratic or either you will get a square root of quadratic. So for these two forms we are going to have this sum of the steps and you have to do that and you can be easily solve this kind of integration. Okay, so the first step here is to express your numerator, that is px plus q, as a times the derivative of the denominator. Now denominator, whatever quadratic that you have, a times the derivative of denominator plus b. So if you do the derivative of ax square plus bx plus c, you will get 2ax plus b plus b. Okay, now we have to find the value of capital A and capital B. These are the constants. After doing that, we can express your I, whatever the question will be, that can be equal to a times the derivative with the a part, okay, outside. Since it is a constant, we can take that outside. So integration of 2ax plus b upon the quadratic term plus capital B times, you will be able to find the capital B value, then integration 1 upon ax square plus bx plus c. Okay, now let's just take the first integration as I1 and second one is I2. So the first can be evaluated by using this property, that is the integration f dash of x upon f of x. So in the numerator you will have a derivative and in the denominator you will have an actual function. So in that case you will use this formula, which is log of the function. Okay, right. Now for the I2 can be evaluated by express it in one of the forms. Okay, so if you are having the px plus q upon the quadratic form, that is ax square plus bx plus c, so you can express it in any of these three forms, that is 1 upon x square plus a square, 1 upon x square minus a square and 1 upon a square minus x square. Okay, and if you have a question where in the denominator you have under root of quadratic term, that is ax square plus bx plus c, so in that case you will be able to express it in these three forms: 1 upon square root of x square plus a square, 1 upon square root of x square minus a square and 1 upon square root of a square minus x square. Okay, now after expressing it in each of these forms, each integration have their specific formula. Okay, these are the formulas. If you don't have it, you can just copy it down, because we are going to use this same formula in the upcoming sums. Okay, I have noted this down for you, you just copy it. Okay, now we are going to solve this first sum, that is I is equal to integration 2x plus 3 upon 2x square plus 3x minus 1. Again in the numerator, if you see, it is a linear term because we have a highest power as 1, and in the denominator we have a quadratic term because the highest power is 2. Okay, now we will follow the same steps. First we will express your numerator in the terms of a times the derivative of denominator plus b. Okay, so I'll just write it here: 2x plus 3 is equal to a times derivative of denominator, whatever denominator you have you can write it here, plus b. After this you can take the derivative, so that will give you 2, the derivative of x square is 2x and the derivative of 3x is 3 plus b. If you can just solve it further, that will give you 4x plus 3 plus b. So this is your numerator. Okay, now we'll keep this aside as the equation 1. What we can do further is we can equate the terms. Okay, so multiplying a inside, that will give you 4a times of x plus 3a plus b. Now if you can see, 3a plus b is the constant term, and on the left side you can take the coefficients of x. Here the coefficient of x is 2 and here the coefficient is 4x. Okay, so we can just equate the terms of x that will give you 4a is equal to 2, a is equal to 2 upon 4, that is 1 by 2. So you have got the value of a as 1 by 2. Okay, then we can equate the constants. These are the constant 3 on the left side, and on the right side we have 3a plus b. 3a plus b is equal to 3, but we already have the value of a. We can substitute here, that will give you 3 by 2 plus b. So b will be equal to 3 minus 3 by 2, that will be again 3 by 2. So we have got the value of a as well as the b. Okay, now we will use the same equation number 1. Okay, so from equation 1, 2x plus 3 is equal to a. A is nothing but 1 by 2, 4x plus 3 plus b is 3 by 2. Okay, now we will write the integration. So in the numerator we can write 1 upon 2 4x plus 3 plus 3 by 2. So your numerator got replaced by this bigger term, but your denominator will remain same. Okay, now we can just separate this, so that will give you 1 by 2 integration 4x plus 3 upon 2x square plus 3x minus 1 dx. I have given the denominator to the first term, that is 4x plus 3, and we are giving the denominator to the second term, which is 3 upon 2. Okay, so we are on the step number 3. If you can see here, we have taken the a outside, integration, the derivative we have written upon the denominator, plus b times integration 1 upon this. So here it is. Then 3 by 2 integration 1 upon 2x square plus 3x minus 1 dx. Okay, now we will write this as I1 and this as I2. Okay, so it will be better and it will be very simplified if you just do it separately. Okay, so let's do it I1. So I1 is 1 by 2 4x plus 3 2x square 3x minus 1 dx. Now I have told you how we can evaluate the I1 by using the property integration f dash of x upon f of x. You can just verify here, in the denominator we have 2x square plus 3x minus 1. If you take the derivative of the denominator, you will get 4x plus 3. Okay, so we can directly write the answer here, which is log of mod 2x square plus 3x minus 1 plus c1. Since we are evaluating for I1, so the constant will be c1. Okay, so we have used the same formula for the I1 part. Okay, this is your f dash of x and this is your f of x. So the formula was log of mod f of x. Okay, now just move on to I2. So I2 here is 3 by 2 integration 1 upon 2x square plus 3x minus 1 dx. Okay, now this is a quadratic term in the denominator, so we have to take the 2 common. So that will give you x square plus 3 by 2x minus 1 by 2 dx. Why we have taken it? Because we have to complete the square in the denominator. So in order to complete the square, you have to make the coefficient of x square as 1, and to make the coefficient of x square as 1, whatever number that you have, you can take that common. So that will give you 3 by 4 integration 1 upon x square plus 3 by 2x minus 1 by 2. Now in order to complete the square, we have to find the third term. So third term is half into coefficient of x. Coefficient of x is 3 by 2 the whole square. That will be 3 by 4 the whole square, which is 9 by 16. So we have got the third term as 9 by 16. So I2 will be 3 by 4 integration x square plus 3 by 2x. We'll add the third term 9 by 16. Then we will subtract the third term and then we will write minus 1 by 2 what we already had. Okay, then I2 will be equal to, so here after doing this will be 3 by 4 integration 1 upon, take the square root of the x square, square root of x square is x and the square root of 9 by 16 is 3 by 4. Take the sign of the middle term which is plus and put a square here. Okay, now in order to evaluate this term, what we will do, we'll do the LCM. We'll multiply this by 8, we'll multiply this by 8. Okay, so what we'll get here, minus 9 minus 8 which is minus 17 upon 16 dx. Okay, so this will be 3 by 4 1 upon x plus 3 by 4 the whole square minus, you have to write this also in the square form, so square root of 17 upon 4 the whole square. Now if you can see, this is in the form of 1 upon x square minus a square. Okay, so we will apply the formula that I have shown you. Okay, the same thing that we are going to do here. Okay, so the formula is 3 upon 4 1 upon 2 times of a. So a here is root of 17 upon 4. Okay, this is multiplied, this is multiplied, then log x plus 3 by 4 minus root of 17 by 4 the whole upon x plus 3 by 4 plus root of 17 upon 4 plus C2. Now this 4 and 4 will get cancelled, so we are left with 3 upon 2 square root of 17 log, and we have to do this. So in order to do this, we can just take the LCM as 4, the common denominator 4. So we'll multiply in the numerator and denominator by 4. So that will give you 4x plus 3 minus root of 17, and this is 4x plus 3 plus root of 17 and plus C2 we got. Okay, so we have got the value of I1, we have got the value of I2. So we'll write the final answer here. So I will be equal to 1 upon 2 log 2x square plus 3x minus 1 plus, then it is 3 upon 2 square root of 17, then log. So we have got that part of log, so we'll write that log 4x plus 3 minus root of 17 and 4x plus 3 plus root of 17. That's it. We'll write the capital C here, and capital C will be C1 plus C2. You have to write this, don't forget. Okay, so this was it. This was the first sum, which was the linear term upon the quadratic term. Okay, now we'll solve one more example based on the next one, which is linear term upon square root of quadratic term. Okay, so the second one, I is equal to integration 3x plus 4 upon, then we have here is, we'll take a square root first, that is 2x square plus 2x plus 1 dx. Okay, now again we'll take a numerator is equal to a times derivative of denominator, whatever denominator you have a quadratic term you can take it, plus b, then you have to take a derivative of that part, which is 2, and this is 2x plus 2 plus b. So you have got 4x plus 2 plus b. Here it is on the left side 3x plus 4. Now after doing this, you can multiply this you can keep this aside first, then now you can multiply this a inside, so that will give you 4a times of x plus 2a plus b. This is a constant part, and this is now equating the coefficient of x, that gives you 3 is equal to 4a. So a is equal to 3 upon 4. This is 2a plus b, which is again 4. So we already know the value of a, so we'll substitute here 3 by 4 plus b is equal to 4. So that will be cancelled by 2 times. So we left with 3 by 2. So b will be equal to 4 minus 3 by 2. So that will give you 5 by 2. We got the value of b. Okay. So this was a, this was b. Now from equation 1, we'll take the equation 1 again and substitute the value of a and b. So 3x plus 4 now can be written as 3 upon 4, 4x plus 2 plus b is 5 upon 2. I'll write it again this. Okay, that's it. Now we'll just integrate this part. I is equal to, we'll replace this integration 3 upon 4, 4x plus 2 plus 5 upon 2, the whole upon square root of 2x square plus 2x plus 1 dx. I will separate this. So that will give you 3 by 4 integration 4x plus 2 upon square root of 2x square plus 2x plus 1 dx. We'll take 5 by 2 also outside. That will give you 1 upon square root of 2x square plus 2x plus 1 dx. So we'll take this as I1 and another one is I2. Okay, let's move on to the next page. So I1 is 3 upon 4 integration 4x plus 2 upon square root of 2x square plus 2x plus 1 dx. Okay, now we are going to evaluate this one, but here we don't have that property which was the f dash of x upon f of x, because here in the f of x we have a square root in the denominator, so we cannot apply that property. So what property you can apply? Now this has been already been given, so I'll write it here, the extra property which can be used in this case, that is the integration f dash of x upon square root of f of x dx is equals to 2 times, okay, that will be equal to 2 times square root of f of x plus c. This is the form that you can use, but you have to always verify that in the numerator you should have the derivative of that denominator. So here we already have it, so we can directly write, and in the reason you can write it on the right side. So that is the nothing but 2 times square root of 2x square 2x plus 1 plus c. Okay, so here is your f dash of x and this is your f of x. Okay, hope you understood. Now this can be cancelled 2 times, so that we get 3 by 2 square root of 2x square plus 2x plus 1 plus c1 will write. Okay, we have got the value of I1 now. Now we'll go for I2. So for the I2, I'll write it here, which is 5 upon 2 integration 1 upon square root of 2x square plus 2x plus 1 dx. Again we'll take 2 outside, so if you take the 2 outside it will come with the root part. Okay, so we'll take root 2 outside, so that will give you square root of x square then x plus 1 by 2 dx. Okay, now we'll calculate the third term, because we have to do that part, right? So in order to complete the square, third term is necessary. So third term will be half into coefficient of x. So what was the coefficient of x? Coefficient of x is 1. So 1 the whole square, which is 1 by 4. So now I2 will be equals to 5 upon 2 root 2. If you remember, we already had 2 and the root 2. So we'll write here integration 1 upon square root x square plus x plus 1 by 4. We have added the third term. Now we'll subtract the third term, and what was the constant here, which is plus half. So plus half we had. Okay, now this will be 5 upon 2 root 2. We'll write this in the square form. So that will be x plus 1 by 2 the whole square, and you can evaluate this by doing the LCM directly. Okay, so that will be minus 1 plus 2, that will be plus 1 by 4. Okay, so 5 upon 2 root 2 integration 1 upon square root of x plus 1 by 2 the whole square plus 1 by 2 whole square dx. Okay, now we have come across the integration 1 upon square root of x square plus a square. Okay, so I'll apply the formula here. That will be I2 is equal to, we'll take it on the next page because since it is a big formula, so that will be 5 upon 2 root 2. So the formula was log x, log mod x we have to take. So x is x plus 1 by 2 plus the square root of x square plus a square. So we'll write the same thing, x plus 1 by 2 the whole square minus 1 by 2 the whole square plus c2. Now this will be 5 upon 2 root 2 log x plus 1 by 2 plus. Now you don't have to solve this, you can just see from where we have got this term. We have got this term from this one. Okay, so if you just open that part, you will get this term only. So you don't need to write it down again or expand it. You can just copy it from here. So that will be under root of x square plus x plus 1 by 2. Okay, that's it, plus c2. So that's it, we have got the value of I2. Now the value of I would be 3 by 2 square root of 2x square plus 2x plus 1 plus 5 by 2 root 2 log x plus 1 by 2 plus square root of x square plus x plus 1 by 2 and plus c. Now this c is equal to c1 plus c2. You have to always mention this. Okay, so this is how we solve this kind of integral. Okay, hope you have understood this. This is a very important form and it mostly comes for your exam. So hope you understood this. If you have got any doubts, just let me know in the comments. Thanks for watching, and please do subscribe my channel and also share it with your friends. Thank you so much.